This tutorial is a number of firsts for me. It's the first time that I've given a tutorial on ixml. It's the first time I've given a tutorial from a hospital, and it's also the first time that the software that we're about to use has been exposed to more than one person, namely me. I've tested it, I've simulated it's running on being given programs from lots of people simultaneously, and it works then, but you never know when during a live show things can go wrong. But anyway, I'm watching the server as I talk, and I saw somebody was just testing it out a few minutes ago, so it's definitely working. Anyway, let's get going, because the sooner the better. Okay, so Irreducible XML, it's new. It's a method for treating non-XML documents as if they were XML. It's a work in progress, so what I'm teaching you here is very close to the final version, but it may differ in details, so beware of that. The software is definitely not the final version, and it's not industrial strength, so please bear with me if it doesn't work entirely well, but as I said, I've got my eye on the server and watching as it works. That link you should follow along with, because that's where the exercises are in. So that's http://www.cwi.nl/Stephen/ixml/tutorial. And if you go there, then you can sort of follow along. And if I don't cover all the material today, you can finish it off tomorrow or another day. Okay, so how does it work? So you have one or more documents in a non-XML format. You supply an ixml description of that format, which includes details about how it should be converted to XML. And the ixml processor then uses that description to read and convert the documents to XML. So I'm going to give you a first example. Now you're going to see lots of dates, and the reason that dates are a great example is because A, they're small, so the examples will be small and manageable. B, there are lots of different ways of writing dates. Well, no, those are the two reasons. Okay, so imagine we've got a date like 4th of November 2021. So I'm going to describe this in ixml. So I say a date is a day followed by a month followed by a year, whatever those three things are. Now I have to describe those three things. So a day, for instance, is a digit, or, that semicolon means or, a digit followed by another digit. So in other words, a day can either be one digit or two digits. A digit itself can be 0 or 1 or up to 9. You can single or double quote literals, they both work. Then we define a month, which is just 12 strings, January, February to December. And finally, we say a year is just 4 digits. Now, there's one thing missing, because I said a date was a day followed by a month followed by a year. But in fact, you see here there are spaces between the day, the month, and the year. So I'm going to change that rule so it says day, a space, a month, and a year. Now, if we feed that through ixml, we get something, we get XML that looks like this. And what you can see is that everything that I've described has turned up as an element in the output. So your first task now is in that tutorial link that I just showed on the screen. Go there. There's a link there to how you upload a file. What you should do is copy and paste the ixml from the examples I've just given into two files. One, the ixml file, call it anything, literally anything you like, but for instance, dates.ixml. And then the input that you want to use, for instance, 4th of November 2021, you put that into a second file, and you can call that dates.txt or whatever you want. It's probably handy if you could call them both date, but what comes after that doesn't really matter. Then on that page where you can run ixml, you click to load the ixml file, and you click to load the input file, and then you press run, and bingo, hopefully you should get the answer. So that's your first exercise. Ooh, and I can see the examples flowing in. 1, 2, 3, 4, 5, 6, 7 people already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26, 27, 28, 29, 30. Anybody want more time?
Not more time, but I'd like to see a solution because I got errors.
Okay, and what errors did you get?
Rule name expected. Let me see if I can post it.
Okay, well, so every chapter has an example solution. If you look in the from the digit colon blah 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 blah, not rule name expected. I think that's because have you got one space digit as the rule name?
I haven't got a rule name.
Oh.
Sorry. No, isn't the rule name the thing before the colon?
Yeah, and it should just be a digit, and it looks like one digit. You've got one space digit or something.
I wonder whether this might be a Windows lib Unix thing. Let me. Yeah, it might be. It might be that.
Okay, might be. I can't imagine what, but so there's nothing before the word digit. There's no characters before the word digit. Okay, so your results, assuming it worked in some way or another, should have looked like this. And so what you see is every single rule appears in the output. Now we don't really care about the digits. We only care about the day, month, and year. So what we do is we change the digit rule to and put a minus at the front of it. And if you do that, then all the digit elements, but not the element content, disappear. And then you get something that looks more sensible. So please now do that. Put a minus in front of the digit rule and run it again.
Just confirming, I did a DOS to Unix on the file and it's fine. So that was what it was.
Oh, okay. All right. Thanks for the warning. Okay, the results are coming in slower, so I'll move on. So that shows you how you can sort of suppress an element, but you can also say, I don't want it as an element, but I want it as an attribute. For instance, if you put an at before the year rule and then run it, you get the date with the year as an attribute and then the day and the month as elements. So what I now want you to do is make all of those, year, day, and month, into attributes and run it. So if that last exercise worked, you should have had an output that looks something like that. And you might wonder why it's not an empty element. And that's because every single bit of the input ends up in the XML unless you say otherwise. So what you've got in that date element there are two spaces that are the spaces between the 4 and the November and between the November and the 221. So if we want to exclude those spaces, what we do is we take the date rule, where that's got the spaces in them, and we add a minus before the two literal spaces. So that's what I now want you to do. Okay, so that's some basic stuff. Now, we defined a day as either a digit or a digit followed by a digit. We can write this as a different way, as it's a digit followed by an optional digit with a question mark after it. So try that out. Try putting the question mark on either of them. Experiment with the year optional as well. Okay, so if you got round to the bit where it said make the year optional, if you did it like this by just putting a question mark after the year, that makes the year optional, but not the space before it. So you could get around that by making a separate rule that says a date is a day and a month and an optional year, where an optional year is, excuse me, a space and a year. But it's easier and better to say a date is a day and a month, and then bracketed a space and a year, and that bit being optional. And then if you run that on a date with no year, what will happen is that no year element will get produced because there's nothing there. So you'll get something like that. A date is a day and a month. What I want you to do is now make the year optionally 2 digits or 4 digits, and to do that with grouping. All right, so now we get to repetition. So you can place a plus sign after any item to mean one or more. So for instance, if we want to allow more than one space between the day, the month, and the year, then we just add a plus after the space. You can use a star to mean 0 or more. So for instance, in that second line there, the second example, that says a date can begin with 0 or more spaces, then the day, then 1 or more spaces in the month, and then 1 or more spaces and the year. Another way of doing the same sort of thing is to create an explicit rule for spaces. So you see here the rule S allows 1 or more spaces. And then we use that between day, month, and year, and we say it's optional before the date. So then we've got effectively either no spaces or 1 or more spaces before the date, and then spaces between the elements. And if we now want to allow any number of dates in the input, then we can just say dates is date plus. And so then your input can contain any number of dates. So that's what I would now like you to try.
I had a question about the definition of the S rule.
Yeah.
Could you explain why it's defined as minus S instead of just S?
So that it doesn't turn up as an S element in the output.
But isn't S defined already as a minus?
Yeah, but then
around the space.
So you've got the minus before the space, but then you would get an empty S element. I mean, give it a try. But what will happen is that everywhere you've got S, you'll get an S element that's empty because we've got a minus before the spaces.
Could you do it the other way around and define the S, well, just as S instead of minus S, and then in your date rule, use minus S? Or,
that comes later, but yes, the answer is yes, you can.
All right, thank you.
Okay, so some shorthands for character sets, which was sort of suggested in the chat just now, although there are more shortcuts coming as well. But here, where we've explicitly said a digit is, and then those 10 values, we can do a shortcut with square brackets and say from 0 to 9. Similarly, you can say a letter is A to Z, semicolon, capital A to Z, or you can say an operator is, and then a string, or a hexadecimal digit is 0 to 9, and then either capital or lowercase A, B, C, D, E, F. A character set like this matches a single character taken from the set. There's also the complement of it, where you put a tilde before the character set, and that says any character except what is in the set. So here's a nice way of defining a string. We say it starts with a double quote, then any number including 0 of characters that aren't a double quote, and then a double quote. Since the empty set doesn't match any character, tilde empty set matches any single character. So my next example requires you to start doing some writing of your own. So accepting a list of strings. So basically strings, some spaces, strings, and in the tutorial link, you'll see an example of the output that I'm expecting. Any questions? Go for it. Right, I've got 2 more slides before the break, and you can finish in. You can do your exercises more in the break if you want. So I'm going to move on to repetition with separators. So we've already seen repetition in 2 forms: 0 or more, such as spaces can be a space star, or dates can be date plus, which requires at least 1 date. Separators allow you to specify what comes between each repetition. For example, a list of numbers separated by commas, you'd say number plus and then the string comma. If you wanted to separate the numbers by commas and spaces, you use grouping. And so you say number plus and then a comma followed by any number of spaces. Of course, it works with star as well as plus. Anything can follow the plus: a rule name, a group, a literal, a character set. So I'd like you now to take your list of strings example, and instead of having spaces between the strings, having commas and spaces between the strings. Okay, go. So there are different ways of doing options. And apart from using question mark, as you saw earlier, you can specify that something's optional in a different way. For instance, this rule for year, I've added semicolon and then nothing. So it says that a year can be 4 digits or nothing. If you want to make it more obvious, you can give that nothing a name. So for instance, 4 digits empty, where empty is also nothing, but it makes it stick out a bit more. If you use that form of an option, what you do is what happens is that you get an empty year element rather than an absent one. So the choice is yours, or what you want from the output. So that's come to the top of the hour for me. So there's a 15-minute break. You've got an exercise to write a piece of ixml yourself. Try and specify what an email address looks like. Make your own decisions. It's not entirely important that you get it exactly right, but just to rehearse using ixml. So the essential purpose of XML is to convert non-XML formats into XML. And it's not particularly to check that the input is correct. For instance, the date format that I gave earlier also accepts inputs like 0 January 2021 or 99th of December 9876. You may not care because you know the data is correct and you just want it in XML. But if you do care, then we can do some checking. So, for instance, and you'll see later why this is interesting to do this way. We can use ixml to check the data up to a certain point. For instance, by excluding 0 as a single digit and only allowing 2-digit numbers up to 31. So we can say a day is an optional 0 followed by any of the digits except for 0, or 1 or 2 followed by any digit, or 30 or 31. So you now have an exercise to restrict dates. In this case, it'll be day and month. Oh no, not even month. But to do this and give it a try. So we're going to add ISO dates to the mix. ISO dates look like year dash month dash day, and so as you can see here, I've got date in the same day space month space year, or ISO, where ISO is the year dash n month dash day. N month because it's a numerical month, not an alphabetical month as in the first date. So a numerical month is just 2 digits, a digit followed by a digit. Now the ixml accepts both sorts of dates, so it recognizes which one it is and produces the output for the one that it discovers. So in the tutorial link, you'll find an example of how dates are represented in HTTP between servers. So I would like you to write a bit of ixml to recognize HTTP dates. Well, you can either start again or add this to your existing set of date formats. It doesn't matter. It'll work if you just add it to the list of dates and ISO and so on. But now we're going to add another date format, the one that uses slashes like 31/12/1999. So to do that, we say date is a day, a slash, a hidden slash, a month, a slash, and a year. And a day is 0 to 29 or 30 or 31, and a month is 0, 1 up to 12. A year is 4 digits, and the digits is the same as ever. Now that's how most of the world writes slash dates, but in the US they write it with a month first, so we'll add that as well. So we'll say a date is a US format or a world format, and a world format is day, month, year, and the US format is month, day, year. Now, if we give it the date 31st of 12th, 1999, we'll get date, world, day 31, month 12, year 1999. If we give it 12/31/1999, then it'll say date, US, month 12, day 31, year 1999. But if we give it the 4th of November 2021, it's ambiguous because you can't tell which is the month and which is the day, and so you can't tell if this is a US date or a world date. So what ixml does, it says that it didn't know, it found two possible solutions in this case, and it's ambiguous between US and world. You'll also see that it adds, it gives you one of the solutions, but it marks it as ambiguous. So it chooses one at random. You can't say how it chooses it, just so that you know it might not be what you expected. So your exercise now is to do that. Try it out and see an ambiguous date.
I wonder if you might explain the square bracketed locations in the ambiguous message.
Oh, well, I mean, this is not a part of the spec, but so I'm just giving a bit of extra help. But so it says, in parsing a date between line 1, position 1 to line 2, position 1, it's discovered that the input can either be a US, a production of US, or a production of world. So it's saying that date can produce US or world at that position.
Thank you.
So what I'm pointing out here is ambiguity, and the ambiguity can be inherent in the language, like the previous example you just saw, but it can also be, as it were, your fault because you've described the format ambiguously. I just have to call the nurse to change my drip. So for instance, if I define dates as just date plus, in other words, a string of dates, and a date could have both spaces before and after it, then if I've had two dates like 4th of November 2021, some spaces, 5 November 2021, ixml wouldn't know if those dates those spaces are following the first date or preceding the second, or maybe a bit of both. So you have to be careful how you define your rules so that you don't make ambiguity. In this case, it wouldn't matter because the result would be exactly the same in both cases, but it's still better not to have ambiguous grammars if you can avoid it. Similarly, if you defined an expression as either a number or an expression with an operator and then an expression, then again, ixml wouldn't know whether in 1 + 2 + 3, whether the 1 + 2 is one of the expressions or 2 + 3 is the other expression, because they will both match. So you would get a complaint about that. So your exercise now is in the ambiguous date example, world and US, to make the ambiguity explicit. That is to say, add a third version. So you have world, US, and ambiguous, so that ixml doesn't complain about an ambiguous date. You can just get an element that says ambiguous. You can see an example of the output that I'm expecting in the tutorial link. Okay, this is a bit tricky. You probably won't get it done in the time, but it's something that you can do as homework afterwards if you don't get through it. So let me continue. We've got another quarter of an hour or so. So there are certain things you can't describe in ixml, so it's only honest to tell you something about that. ixml can only describe context-free languages, and that's languages, roughly speaking, where the content of the document doesn't affect the structure of the document. To give you an example, Fortran, the programming language Fortran, had strings, but you had to count the number of characters in the string and then say, for instance, 6H string. And you can do that for sort of special cases in ixml, but not the general case where you've got a number, the letter H, and then that number of characters. You can't describe languages in a general way where the structure is only implied by the indentation, nor where structures are silently closed off by some nested structure. Luckily, most languages are designed to be context-free, and so it usually won't be a problem. I did have an exercise for this, but it's quite a long one, and I think I'll jump over it and allow you to do that after the tutorial. So I'll just move straight on. Now, ixml uses Unicode for its character set, which has many thousands of characters. I looked it up yesterday. It's currently at 144,697 characters in Unicode. Now, Unicode classifies characters in different ways, and ixml uses those classifications. You can only use them in character sets. So, for instance, class capital L covers lowercase letters, capital LU is uppercase, and class capital L covers all characters that are considered letters. In fact, there are 130,000 of them. So the idea is, nobody's expecting you to know what a letter is if you want to be able to handle international names, for instance. So you could define a name as just L plus, in other words, any number of letters. Similarly, class ND covers decimal digit characters, internationalized. So you could define a number as as any number, one or more NDs. The software you're using, or we're using today, doesn't yet work for all of Unicode. It only works for ASCII. Something that's got to be fixed yet. But you can still use them to try them out. So your exercise now is to create a description of a list of names and numbers. So you can have several names, several numbers, or several mixtures of names and numbers. Okay, go. So serialization overrides. As we have seen, you can hide under element, for instance, minus digit, or you can output it as an attribute and say at number is digit plus. But so these are sort of defaults, but you can override these defaults when you use a rule. So as an example, if your input contains either a single date or a pair of dates representing a start and end, like this example at the top here, you could write rules that says your incoming data is either a date or a range, and a range is a start, a colon, an end. Now, date is just regular, what we've done up to now. And at the bottom there, you see start is minus date and end is minus date. That says its syntax, its structure is just like a date, except we don't want to output it as a date element. So in other words, you get a start element with the content of the date element. So that if I give it this input, then I get data, date, and then the regular structure. But if I say, if I give it a range, then I get data, range, and then the start, year, month, day, and end, year, month, day. Just in passing, the root element, you can make it hidden if you want, as long as its resulting content is a single element, but that's because XML rules. So if we replace the data rule from the previous page with minus data, data range, then we'll either get a date out of it or a range, and it'll drop the data element. To override a rule that's hidden or an attribute, to make it into an element, you use a circumflex like that. So for instance, in this example, my input is either a digit or a number, where a number is 2 or more digits. Digit by default is hidden, but in the top line, I've made it an element. So if I give it input 2021, we get input number, and if I give it input 4, we get input digit. So you can overrule or override the default action of a rule by making it an element. And similarly, you can overrule it to make it into an attribute. So if I said my input is a @ digit or @ number, then that overrides the default representation of numbers and digits, so that I get input with an attribute digit equals 4 and input with an attribute number equals. The next one is a big exercise, so I'll skip that now because we've got 5 more minutes, and I'll just finish the elements here. You can include any Unicode character in a literal string, but occasionally it's useful to be able to be explicit which character is intended. For instance, tabs or non-breaking spaces are hard to distinguish from a space visually. In such cases, you can specify the character as a hexadecimal number, which is just its position in the Unicode sequence. So a tab is #9, a non-breaking space is #A0. These match a single character in the input, so you can use it just in the same place where you can use a string, but you can also include them in character sets. You can't include them inside strings, and you don't need to, because it doesn't add any power. So if I said quotes #A0, that would stand for just the 3 characters #A and 0. This exercise is quite fun to do, where you've got numbers only separated by tabs. But again, we don't have time for you to do that right now, but please go back and do it some other time. So this is where we come to the end. Where next? Well, one thing is worth looking at is the ixml definition of ixml in its specification. For instance, a rule is defined as an optional mark followed by spaces, a name, spaces, either an equals or a colon, spaces, and then alternatives, and a full stop. So you can read that now, having learned all about ixml, and what you can see is that rule is actually defining itself. So there, 5 to the hour. It just gives a little time for questions if we want. I fear that the server will go down when I close my laptop. I will try to do a no hop on it when I close it, so that you can continue playing. But once I get home, I'll restart it, and then you can carry on playing. Are there any questions?
Stephen, there is a question from Eric, and I had the same idea. Why aren't you using more the regular expression syntax that we know in XPath? Okay, so
yeah, okay, well, the answer is that I am sort of, but in fact, this is more powerful than regular expression. You can describe much more than regular expressions. So the answer is because this is better.
Okay, maybe everybody can try to switch on their videos, switch on their sounds, and as Norm suggested, do a screaming fanboy applause for this hospitalized speaker and tutor. I think it was wonderful and it was great. And I want to thank all tutors today, and we'll see each other tomorrow. Let's clap.